Right, Sima. Next exercise 7.10. In this exercise, he given only substitution. So substitution already I told. So whenever if we converted one variable to another variable, substitution method must and should be remember one point. If we change that related limit values here, which variable limits there, if we converted another variable, must and should be converted into that limit value, that particular variable limits. After then we are applying the same process. Okay na? Right, Sima. So exercise 7.10, evaluate the integrals in the following. First question given here, integral x by x square plus 1 dx, x square plus 1 dx, 0 to 1, limits 0 to 1. Here we are applying the substitution method. So that's why what we done here, x square plus 1 is equal to t. Now what is the derivative of x square? 2x dx is equal to dt. X into dx is equal to how much? Dt by 2 value. Then immediately if we change the limits, for limits what we find out here, x is equal to 0, then what is the t value? Related x is equal to 0, then t is equal to 0 plus 1, 1 value. Next x is equal to 1, then what is the t value? T is equal to 1 plus 1, 2 value. Okay na? This is compulsory if we converted limits in terms of that variable. Otherwise directly if you miss, that process is wrong. Answer also if you get the wrong answer. So now if we take this value, integral 0 to 1 x by x square plus 1 dx is equal to, limits what my here, integral 1 to 2, integral 1 to 2, x dx is equal to how much here? Dt by 2 value into 1 by t value. Now what we done here, that is equal to 1 by 2 into log t, limits 1 to 2 value. Then what we done, log 2 minus log 1 means log 2. So that is equal to answer 1 by 2 into log 2, upper limit log 2 minus log 1, log m minus log n, log 2 value. Right, second bit Sima, second bit integral 0 to pi by 2, integral 0 to pi by 2 square root of sin phi, square root of sin phi into cos power 5, cos power 5 into d phi value. Okay na? D phi. Now this is also same substitution method, but if we change some conditions here, x power 5 if you written in terms of sin, how to write x power 5 in terms of sin? Integral 0 to pi by 2 square root of this value sin phi value. Yes, this one cos power 4 pi into cos phi. Then cos power 4 means what? Sin square. So that's why what we done this value, 1 minus sin square phi whole square into this value how much cos phi into d phi value. Okay na? So 1 minus cos square phi, 1 minus sin square phi, cos square phi. Cos square phi whole square how much? Cos power 4 pi. 4 phi into cos phi, cos power 5 phi. Now if we take the substitution here, sin phi is equal to t. Then what we have done here, cos phi d phi is equal to dt. Now limits, if we change the limits, then what we have done here, phi is equal to 0. Then t is equal to sin phi. Sin phi means sin 0, 0 value. Next, phi is equal to pi by 2. Then what we have done, t is equal to sin pi by 2. Sin pi by 2 is equal to 1 value. Now if we give the limits, integral here 0 to 1 value, integral 0 to 1. So root t value into, so this value 1 minus t square whole square, cos phi d phi is equal to dt value. Okay na? Now if you write on this value, integral 0 to 1, so t power 1 by 2 into a minus b whole square formula, 1 plus t power 4 minus 2 into tt this value. Now that is equal to integral 0 to 1. So this value how much more? T power 1 by 2 plus t power 1 by 2 plus 4, how much more? 1 by 2 plus 4, 8, 9, t power 9 by 2 minus 2 into t power 1 by 2 plus 2, 4, 4 means 5 by 2 into dt. Okay na? Now if you substitute the integral value, see integral t power 1 by 2 means t power 1 by 2 plus 1, 3 by 2. So means what here? 2 by 3 t power 3 by 2. Next 9 by 2 plus 1 ma 11 by 2. 11 by 2 means 2 by 11 t power 11 by 2 minus 2 into 5 by 2 means ma 5 by 2 plus 1 7 by 2. 7 by 2 means 4 by 7 t power 7 by 2. Limits what ma here 0 to 1 value. Limits what ma here 0 to 1 value. Okay na. 0 to 1 value. So now here we substitute the values 0 to 1 limits there. Then what we written this values is equal to t plus 1 if you written means 2 by 3 plus 2 by 11 minus 4 by 7. Remaining values 0. Minus half 0 plus 0 minus 0. Lower limit is totally become as 0. Now here see LCM how much we taken here? 77 into 3, 77 into 3, how much ma? 231, this value how much ma? 231 LCM. Now 3 table if you taken means ma, how much? 3 7s are 370, 77 into 2 ma? 4 again 14 means 154 plus 11 table if you taken means ma? 11 2s are 11 1s are 21, 21 means 42 minus this value ma? 7 table, 7 3s are 21 33 means 14 12 next month 12 means 132. So overall if you see 64 by 231, this value how much 64 by 231 value. Right, see third question, integral 0 to 1 sin inverse of 2x by 1 plus x square dx. Okay na? Now here if we take the substitution, x is equal to tan theta, then theta is equal to tan inverse of x. Now what is the derivative of this value? Dx is equal to secant square theta d theta. Then must and should be we change the limits. X is equal to 0, then what is the value of theta? Theta is equal to tan inverse of x, means tan inverse of 0, 0 value. Now x is equal to 1, lower upper limit, then theta is equal to tan inverse of n pi by 4. Now these values we substituting in the given integral. So 0 place 0 written, 1 place pi by 4, sin inverse of 2 tan theta by 1 plus tan square theta dx is equal to how much? Secant square theta d theta. Now if you write on this value, formula sin 2 theta formula 2 tan theta by 1 plus tan square theta, sin inverse of sin 2 theta into secant square theta d theta, sin inverse of sin x value. So that's why what we are done here. Here see integral 0 to pi by 4 2 theta into secant square theta d theta. So 2 multiple 2 into integral 0 to pi by 4 theta into secant square theta d theta. Now we applying the by parts formula. Now 2 multiple there here, theta first function, second function integration minus the derivative of the first function, integral of the second function, whole integral value. So limits 0 to pi by 4 value. Then what we are done here, secant square theta value, tan theta value, and secant square theta value, tan theta value, limits 0 to pi by 4, 2 into, now limits we substituted upper limit, pi by 4 into tan pi by 4 1, log of secant pi by 4 minus lower limit 0 minus log of secant 0 value. Now here see multiple 2 there are, 2 multiplying these terms, 2 into pi by 4, pi by 2 value, 2 into minus 2, 2 log secant value how much? Secant pi by 4 is equal to root 2 value plus again if you multiplying this value, then what we are done here, this value is equal to, if you taken means here 2 also there, but 2 into log 1, 2 into log 1 is nothing but 0, leave it so root 2 whole power 1 by 2, 1 by 2 2 cancellation, then if you get minus log 2, this value pi by 2. Okay na? Let's see fourth question, integral 0 to 2 x into root of x plus 2 dx value, x into square root of x plus 2 dx value. Now if we take the substitution, x plus 2 is equal to t square, x plus 2 is equal to how much more? T square. Now what is the derivative of this value? Dx is equal to 2t into dt value. Now here see substitution means limits, x is equal to 0, then t is equal to 2 there, t square t square is equal to 2, t is equal to root 2, x is equal to 2, then t square is equal to 4, t is equal to 2 value, t is equal to 2 value. Now we substituted these values, integral 0 to 2 x into square root of x plus 2 dx value, x plus 2 dx value. Now here what we have done here, that is equal to integral 0 plus how much there, this value root 2 there, and this value how much 2 value. Okay na? Now x is equal to t square minus 2. T square minus 2. This value how much more? Square root of t square means a t value into dx is equal to how much more? 2t into dt value. That is equal to 2 into integral root 2. So t into t ma t square t power 4 minus 2 into t square into ma dt value. Next see ma that is equal to 2 into integral. Now we applying the integral value t power 4 value how much ma? T power 5 by 5 value minus 2 into t cube by 3 limits what ma? Root 2 into root 2 to 2 value, root 2 to 2 value. Now here see ma first we write on this value 2 into this value ma t power 5 means 2 power 5 32 by 5 minus 2 cube 8 2s are 16 by 3. Okay na? Minus ma root 5 whole power 5, root 5 whole power 4 means 4 times root 5 if means root 2 into root 2 into root 2 4 times 4 into root 2 4 into root 2 by 5 value minus so 3 times root 2 if it means 2 times 2 into root 2 already 2 there. So 4 into root 2 by 3 value. Okay na? Now simplifying ma this value that is equal to this value ma 64. One thing do it otherwise 2 into this LCM how much ma 15. So 5 3s are so 3 6 96 minus 3 5s are 5 3s are 3 5s are here also value 80. Okay na? Next minus half this value how much more again 15 5 3s are 12 root 2 minus 3 5s are 20 root 2 value. Now that is equal to 2 into this value 96 minus 80 16 by 15 minus 12 means plus 8 root 2 by 15 value. Otherwise if you want to take any common value means how much there here 18 8 common if you taken means this value how much 16 here 2 value there. Okay na? 8 if you taken common means then what would happen here 32 this value how much 32 by 15 plus otherwise 16 root 2 by 15 value. Right, fifth question ma integral 0 to pi by 2 integral 0 to pi by 2 sin x by 1 plus cos square x dx. Sin x by 1 plus cos square x dx. Now here if you write on substitution cos x is equal to t. Now what is the derivative of cos x? Minus sin x dx is equal to dt. Now sin x dx is equal to minus dt. Now if we convert the limits x is equal to 0 then t is equal to cos 0 1 value, x is equal to pi by 2 then t is equal to cos pi by 2 means 0 value. Okay na? Cos pi by 2 is equal to 0. Now here see integral 0 to pi by 2 sin x by 1 plus cos square x dx that is equal to integral 0 means 1 value, pi by 2 means value how much 0. Next sin x dx is equal to minus dt divides sin x dx is equal to minus dt divides 1 plus t square value. One property there in indefinite integrals next we learn that properties whenever here negative value there means if you interchange that upper limit and lower limit then automatically that negative value become as a positive. That property if you learn in next class we learn that properties. Now applying that property 1 to 0 this 0 to 1 then this negative value become as a positive 1 plus t square value. Now what is the formula of this one? That is equal to tan inverse of t value. So tan inverse of t means 0 to 1. So tan inverse of 1 pi by 4 minus 0 that is equal to value pi by 4. Sixth question see integral 0 to 2 dx by x plus 4 minus x square, x plus 4 minus x square. Now if we take this expression means what minus common if it this one if you write first x plus 4 minus x square is equal to minus half negative value become as a positive minus x minus 4 value. Okay na? If we take in this expression minus common, negative value become as positive, both are negative value. Now if we converted this value, minus half x square minus 2 into x 1 by 2. Now if we balancing this value, then what would happen here? 1 by 4 minus 1 by 4 minus 4 value. Now if you run, that is equal to minus half this value x minus 1 by 2 whole square, x minus 1 by 2 whole square, minus this value 4 4s are 16, minus 16 minus 1 minus 17 by 4. So this value if you run 17 by 2 whole square, 17 root 17 whole square means 17, 2 square means 4 value, minus common if we taken means root 17 by 2 whole square minus x minus 1 by 2 whole square. Now that given expression simplification this one. Next what we done here, integral 0 to 2, so dx by, then this value how much root 17 by 2 whole square minus x minus 1 by 2 whole square is equal to formula what 1 by a square minus x square formula, 1 by a square minus x square formula. So 1 by 2a, a is equal to how much here, root 17 by 2 value, root 17 by 2 value into log of this value what would have a plus x root 17 by 2 plus x means x minus 1 by 2 divides this value root 17 by 2 minus half minus x minus half x means minus x plus 1 by 2 value. Now if you substitute the limits, where to where this limits 0 to 2 value. Next step that is equal to cancellation 1 by root 17 log of, here LCM here 2 there, here 2 there, so root 17 plus 2x minus 1 divides this value root 17 minus 2x plus 1. So limits 0 to 2 value, 0 to 2. Next step that is equal to what we have done here, 1 by root 17 into log of this value how much root 17 plus 2x minus 1 Now here we substitute the limits. First upper limit if you have means root 17, this value how much root 17 plus x plus 2 4x minus 1, 4x minus 1 value, okay na. So next limit what we have here by this value again root 17, next this value how much minus 4x plus 1 value, okay na. This is the upper limit, minus lower limit what we have done here, log of this value what we have done here, lower limit. If you want to write on the lower limit, then what we have done here, root 17 minus 1 by root 17 minus 1. Substituted means 2 into 2 how much 4, 4 minus 1 3 value, root 3 plus 3, then again root 17 minus 4 plus 1 minus 3 value, okay na, right. Root 17 plus 1, root 17 minus 1 by this value root 17 plus 1 value, okay na. Now this one if you write on fraction form, then what we have done here, 1 by root 17 into log of this value root 17 plus 3 by root 17 minus 3 into by fraction reciprocal, then what we have done here, root 17 plus 1 by root 17 minus 1 value. Now if you find out this value, 1 by root 17 into log of root 17 into root 17 17 plus 1 into root 17 3 into, next 4 into root 17 1 into 3 plus 3 by again this value root 17 17 minus root 17 minus 4 root 17 plus 3 value. Now that is equal to 1 by root 17 log of 17 plus 3 20 plus 4 into root 17 20 minus 4 into root 17, okay na. So 4 common if you have numerator value, that is equal to 1 by root 17 log of this value 5 plus root 17, this value 5 minus root 17. Again if you want to apply the rationalization, then what we have done this value, that is equal to 1 by root 17 log of this value what 5 plus root 17, 5 plus root 17 by 5 minus root 17 into 5 plus root 17 by 5 plus root 17. So rationalization ma, that is equal to what from here? 1 by root 17 log of. So numerator value multiplying ma, a plus b whole square formula 25 plus 17 plus a plus b whole square ma, 10 into root 17. 10 into root 17 divides ma 25 minus 17, that is equal to ma 1 by root 17 log of this value how much here? 32, 42. 42 plus 10 into root 17 by here how much ma? 8 value. So 25 minus 17 means 8 value. 2 common if you taken ma, 1 by root 17 log of 21 plus 5 into root 17 by 4 value. Right. Seventh one sima, integral minus 1 to 1 dx by x square plus 2x plus 5. Ma this one totally same model, sixth model. Sixth model also if we find out same this one, if we find out that quadratic expression in a perfect square form and we applying the limits that suitable formula. You do ma that one, seventh one, and eighth one sima, eighth one integral 1 to 2, 1 to 2. So 1 by x minus 1 by 2x square into e power 2x into e power 2x. See this one in indefinite integral one formula there, integral f of x plus e power x into f of x plus f dash of x. Now we comparing that formula and we simplifying this value. Now if we take my here substitution, 2x is equal to t rather, 2x is equal to t. Now what is the derivative of this value? 2 dx is equal to dt value, 2 dx is equal to ma dt. Now limits if we change my here, x is equal to 1, then t is equal to 2 value, x is equal to 2, then t is equal to 4 value. Now if you substitute the limits here, integral 1 place how much there ma 2 value, 2 place how much there ma 4 value. Now here what we done here, 1 by x, x is equal to how much? T by 2 means 2 by t minus 1 by this value ma x square means t by 2 means t by 4. So then what we done here, 4 by 2 into t square, 4 by 2 into t square into e power t, dt is equal to how much ma? Dx is equal to dt by 2 value. So that is equal to what we done see here, 1 by 2 integral this value what ma 2 to 4, 2 to 4 here ma 2 by, so 2 also common here see ma 2 ones are again 2 2s are, so 2 by t minus 2 by t square into e power t dt, again 2 common if you taken means 2 2 cancellation, integral 2 to 4, so 1 by t minus 2 by 1 by t square into e power t dt. Now if you know that formula, integral e power x into f of x plus f dash of x dx is equal to what we done the formula, this one e power x into f of x plus c, in indefinite integral this formula there. Now we substituted this formula here, what we done here in this result, if we take my e power x means f of x is equal to f of t is equal to what here, 1 by t value. Now f dash of t is equal to how much here, minus 1 by t square. So that's why this is the f of t function. Then what we done this value, e power t into f of t value, e power t into my f of t. So limits what my here 2 to 4 value, that is equal to e power 4, e power 4, f of t means value how much here, 1 by t, f of t means value how much ma 1 by t means 1 by 4 minus this value ma again another value what here, e square lower limit e square by 2 value, that is equal to sima e square common if you taken, e square common if you taken means here value how much ma e square, so minus 2 by 4 value, e square minus 2 by 4, sima here multiplying e square into e square e power 4 minus 2 into LCM if you taken means 2 into e square by 4 value. Let's see ma, in that exercise questions over ma. Now objective question, 2 questions given, that objective questions, ninth one see ma. So ninth one integral 1 by 3 to 1 given and x minus x cube whole power 1 by 3 divides x power 4 dx given, x power 4 ma dx, okay na. Now if we take the common value in numerator, integral 1 to 3 1, x cube means x cube common if you ma, x cube whole power 1 by 3. Here x only there. X by x cube means 1 by x square minus 1 whole power 1 by 3 divides this value x power 4 dx value. Here 3 cancellation, x there. X power 4 cancellation. Integral 1 by 3 1. Then this value how much ma? 1 by x square minus 1 whole power 1 by 3 by x cube dx value. Now see ma, 1 by x square is equal to t. Now what is the derivative of this value ma? Derivative of this value means x power minus 2. So minus 2 by x cube dx is equal to how much dt value? Minus 2 by x cube dx is equal to dt. Now limits what we have done here, x is equal to 1, then t is equal to 1 by 1 1. So x is equal to 1 by 3, then t is equal to, so 1 by 9, 1 by 3 whole square means 1 by 9, reciprocal means 9 value. Now see then what we substituted here, integral value, this value integral if you consider means that is equal to integral 1 by 3 is equal to 9. So 1 is equal to 1 value only. So 9 to 1. Next, here 1 by x square, t value no. So t minus 1 whole power 1 by 3 divides, see here dx by x cube is equal to minus dt by 2. So minus this value dt by 2 value. Now already I told no. So here negative value if you want to convert it positive means if you interchange that limits lower and upper limit. So 1 by 2 integral 1 to 9, then this negative value become as a positive. So this value how much here, t minus 1 whole power 1 by 3, t minus 1 whole power 1 by 3 into dt value. Now what we have done here, this value that is equal to 1 by 2. So t power minus 1 whole power 1 by 3 plus 1 means 1 by 3 plus 1 4 by 3 divides this value also 4 by 3 limits 1 to 9 value, that is equal to this reciprocal if you taken means 3 by 8 into so 9 minus 1 8 power 4 by 3 minus 1 minus 1 0, okay na. So that is equal to 3 by 8 into 8 means 2 cube, 3 cancellation, 2 square means 16. So that is equal to what we have done here, 8 ones are 8 twos are 3 into 2, that is equal to 6. So option A is correct. Option A is correct. 10th one, here what given Sima? If f of x is equal to, if f of x is equal to integral 0 to x t into sin t dt, then if you want to find out f dash of x, now first we find out the f of x value here what given f of x is equal to integral 0 to x t into sin t into dt. Now we substitute the by parts formula. Then what we have done here, by parts formula means so t first function t as it is written. Next this function derivative integration what sin t means minus cos t, okay na, minus cos t minus integral t derivative 1 again integral of this value minus into minus plus cos t into dt. So limits what here 0 to x limits. Next what we have done that is equal to here minus t into cos t, next plus this value how much here sin t. So limits 0 to x value, that is equal to minus x into cos x plus this value sin x minus half this value 0 plus this value also 0. Now see then what we have done here, minus x into cos x plus sin x value. Now this is the f of x function. Now what we require here, f dash of x. So f dash of x means what we have done here, f dash of x is equal to minus into x into cos x. So x into minus sin x plus cos x, u into v formula, minus means plus this value cos x. Now finally see x into sin x minus cos x plus cos x minus cos x cancellation, x into sin x. Now in the given option, option B is correct. Option B, which option is correct? Option B is correct. Right, indefinite integral. That last concept, properties of definite integrals, properties of definite integrals. So definite integrals, last concept of this one, properties of definite integrals. So these properties are important for board 6 marks question, board 6 marks question, very very important one. Totally 8 properties there. Out of 8 properties, 5 properties very very important, and these statements are very useful for competitive exams, JEE and CET or different competitive exams. These statements are very very important, and we using these statements and we solve the problems. Now we discuss these 8 properties one by one. First one, integral a to b f of x dx is equal to integral a to b f of t dt. Just here we replace x variable place t, another variable. So that's why how to prove that. So already we know that in one condition I explained that definite integral, how to find it. Integral a to b f of x dx is equal to integral a to b f of x dx is equal to what we done here, function value f of x, and we applying the limits a to b, upper limit minus lower limit. Then what we done this value, f of b minus f of a value. So this is equation 1 by 1. And similarly second, so RHL value there. So integral a to b, this value what given here, f of t dt given. So that is equal to again what we done here, f of t. So limits what here, a to b value. Then what we done here, that is equal to again f of b, t place if you substitute the value, limits upper limit minus lower limit. Now we observing from the 2 equations RHL value are equal. So that's why what we done here, from equation 1 and 2. So integral a to b f of x dx is equal to integral a to b f of t dt, f of t dt. Okay na, simple property this one. So this is useful also. Next second property so property 2, integral a to b f of x dx is equal to minus integral b to a f of x dx. So already this property I used you used in a last exercise that where we applying this property, whenever if you interchange the limits, then automatically if you change the sign of the given integral, positive means negative, negative means positive. So then how to prove that? This proof. So first we consider LHL or RHL value, minus integral b to a f of x dx is equal to, then what we done, minus half this function what here, f of x limits v to a limits. Then what we done here, minus half f of a upper limit minus f of b value. Now if you take minus common here, what we done here, f of b minus f of a value. So again this one we consider equation 1. Next left hand side value what, integral a to b f of x dx is equal to, so what we done here, this is also again function f of b x, then this value a to b value. Now what we done here, f of b minus f of a value. So this is equation 2. From 1 and 2 again what we done here, integral a to b f of x dx is equal to minus integral b to a f of x dx value. Okay na? So these two are the first and the second properties, right? Right, third property integral a to b f of x dx is equal to, then here what we done, integral a to c f of x dx plus integral c to b f of x dx value, c to b f of x dx value. Okay na? Now this is the third property. Already if you know that number, this value, any integral means a definite integral means any one curve given. Now if we take the limits a to b, so in between if we take any one point in that closed interval, area of that time I explained this one, any one point we taken. Now this integral, this is the total area, how to split here to a to c and c to b. So that's why this property, that type of property. So this one, how do we prove that means here sim proof. So then first what we take in here, left hand LHL value if we consider, LHL value what given here, a to c f of x dx plus integral RHL value, integral a to b f of x dx. So that is equal to what we done here, this definite integral means what we done here, f of x. So limits a to c value, and again this is also f of x, limits c to b value, that is equal to this one what we done here, f of c minus f of a value, upper limit minus lower limit. Next plus again upper limit f of b minus lower limit. Here see f of c cancellation. Then what we done this total value, f of b minus f of a value. Now this is equation 1 if we consider means. Next LHL value what there here, integral a to b f of x dx is equal to f of x. So limits what here, a to b. Then what we done here also, f of b minus f of a value. From this is equation 2. Now what we are observing from 1 and from equation 1 and 2. From equations 1 and 2, integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx value. So this is the third property. Okay na? Fourth property Sima, important this one, fourth property. Already I told nama for 6 marks question given for 3 marks for this property, and additional one problem given ma, integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx value. Okay na? Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx value. Now if you want to prove this one, if you take some substitution here, what we have done here, let t is equal to a plus b minus x value. So from that equation, x is equal to how much more? A plus b minus t value. Now dx is equal to what we have done here, dx is equal to minus dt for limits. For limits, suppose x is equal to a, then t is equal to how much more? A plus b minus a. So b value. Then x is equal to b. Then t is equal to how much more? A value. X is equal to b means a value. Now if we take the integral a to b f of x dx is equal to integral x is equal to a, then b value, x is equal to b, a value, f of x is equal to a plus b minus t, dx is equal to minus dt. So if you are applying some properties, then second property, negative there means if you interchange that limit, then that value become as a positive. So this value a to b f of a plus b minus t into dt. Next again another property there, if you substituted first property, integral a to b f of a plus b minus x dx value. Okay na? Therefore LHL is equal to RHL. Okay na? Next similarly fifth property there here. So fifth property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, f of a minus x dx value. Now see this one also if you want to prove that same, but substitution, this is also important this fifth one also important. Then see let what we have done here, t is equal to a minus x. Okay now, from that equation x is equal to a minus t, then dx is equal to minus dt. Dx is equal to minus dt. So for limits x is equal to 0, then t is equal to, x is equal to 0 means t is equal to a value, x is equal to a, t is equal to 0. Then what we will see here, integral 0 to a f of x dx is equal to 0 to means 0 place here, a place 0, f of x is equal to how much we taken here, a minus t value, a minus t, dx is equal to minus dt. Now if we interchange that limits, then that negative value become as a positive. So 0 to a f of a minus t dt. So that property, first property, integral 0 to a f of a minus x dx. Again here see LHL is equal to RHL value. Okay na? Sixth property, integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx value, f of 2a minus x dx value. Okay na? So integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx value. Now this is also very very important for that question 6 marks. Okay ma? Now here see already we know that integral 0 to 2a f of x dx. Now if you split this integral, then how to run integral 0 to a f of x dx plus in between point if you select one a. So that's why continuation what we run here, a to 2a f of x dx. So this is equation 1. Which property? This one, third property. In between 0 to 2a if you consider one a point, then if you split this integral. Now if we take the value, let 2a minus x is equal to t in the second integral, on the RHS means what right hand side. Okay na? In this splitting, first we split the given integral in two parts. In the second part, if we consider what we done here, 2a minus x is equal to 2, 2a minus x is equal to t in the second integral on the RH side. So from that x is equal to what we done, x is equal to 2a minus t. From that x is equal to 2a minus t. Now what is the derivative of this one? Dx is equal to minus dt. Now if you want to run for limits, here what we done, for limits, okay na? So x is equal to, first here value how much in this integral number, x is equal to a, then t is equal to, now here x is equal to a right, t is equal to 2a minus a, t is equal to 2a minus a, that is equal to a, and x is equal to 2a, t is equal to 2a minus 2a is equal to 0. Okay na? Clear? First given integral if you split into two parts, now if we take some substitution, means 2a minus x is equal to t, where we substituted this one in the second integral on the right hand side. Now if we take that integral a to 2a f of x dx, a to 2a f of x dx is equal to integral a, x is equal to a means t is equal to how much more? A value, x is equal to 2 means t is equal to 0 value, f of x, from that x is equal to how much here, f of 2a minus t value, dx is equal to how much more here, minus dt value. So already if you know that property, whenever negative value there means if you interchange that negative, then what we are done here, integral a to 2a f of x dx is equal to, minus become as positive. So 0 to a f of 2a minus t into dt. Okay na? So next property what we apply here, instead of the t place if we replace the variable, means the second property integral a to first property integral a to 2a dx is equal to integral 0 to a f of 2a minus x dx, f of 2a minus x dx. Now this value if you substituted in equation 1, Sima, from equation 1, what we done here, integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 a to 2a f of x dx is equal to also how much here, integral 0 to a f of 2a minus x dx value, f of 2a minus x dx value, right Sima? So this is a seventh property. So already what we derived, that is sixth property, both are same properties, but here two cases given. In sixth property if you prove that integral 0 to 2a f of x dx is equal to same up to this one, but here given two cases given. In that property only, if f of 2a minus x is equal to f of x, now if we prove that this value is equal to this one, f of 2a minus x is equal to minus f of x, then if we prove that value is equal to 0. So seventh property derived from sixth property. So that's why now we completed already sixth property up to this one. Here if we using two cases, first case, case 1 what we done here, if f of 2a minus x is equal to f of x, okay na, then equation 2, so this one we consider equation 2 becomes Sima, integral 0 to 2a f of x dx is equal to, now instead of this place f of 2a minus x is equal to what we done here, f of x, then already here integral 0 to a f of x dx there plus integral 0 to a f of x plus dx, that is equal to what we done, 2 into integral 0 to a f of x dx value, 2 into integral 0 to a f of x dx. When this one f of 2a minus x is equal to f of n, that the total integral is equal to that value. Now case 2, if you want to run here, case 2, then what we run here, if f of 2a minus x is equal to minus f of x, then again equation 2 becomes how to run here, integral 0 to 2a f of x dx is equal to, already here what then my value, integral 0 to a f of x dx minus, why you written here, f of 2a minus x is equal to minus f of x value, minus f of x value. So that's why integral 0 to a f of x dx, one is the positive, another one is the negative, that value is also how much more, 0 value, okay na. So finally therefore conclusion what we done, therefore the given value integral, therefore finally if we done with this value integral 0 to a f of x dx is equal to both the cases. So this is the seventh proof property, very very important for board. Let's see eighth property. So last one, this is also important. Already I told last 5 properties are important for board questions. So right here what given, integral minus a to a f of x dx value. Again we split this integral, means 2 parts. Then how to run means integral minus a to 0. In between if you select the value 0 point f of x dx plus integral 0 to a f of x dx value, f of x dx. Now this is also we consider equation 1. Now if we take some substitution here, here what we run means let t is equal to minus x in the first integral, on the right hand side, t is equal to how much more, minus x in the first integral on the right hand side. Then what we will see here, x is equal to minus t, dx is equal to minus dt. Now if you want to find out limits, for limits here Sima, suppose x is equal to, in first integral no ma, x is equal to minus a, then t is equal to, x is equal to minus a means t is equal to how much here, minus half minus a, that is equal to a value. Now x is equal to 0, first integral limits, then t is equal to minus 0, that is equal to 0. Now if we consider first integral, minus a to 0 f of x dx is equal to integral, x is equal to minus a means t is equal to a value, x is equal to 0 means t is equal to 0 value. Then f of x is equal to minus t, f of minus t into dx is equal to minus dt. Again here negative there, negative become as positive means what? If you interchange the limits 0 to a, f of minus t into dt value, f of minus t into dt value. Now if we applying the that first property, so t variable place if you want to write on x variable, then what would on this value totally, integral minus a to 0 f of x dx is equal to integral 0 to a f of minus x dx, f of minus x dx from equation 1. See ma, from equation 1, what will happen here, integral minus a to a f of x dx is equal to, instead of this first integral minus a to 0 f of x dx is equal to integral 0 to a f of minus x dx plus second part what ma, integral 0 to a f of x dx. Now this is equation 2. But here two cases then when we find out these values, if x is even function, now here I done case 1 and case 2. So first I write on here case 1. What write on case 1? If f is even function, then f of minus x is equal to f of x, and equation 2 becomes, then what written here, integral minus a to a f of x dx is equal to, sima f of minus x is equal to f of x, integral 0 to a f of x dx plus integral 0 to a f of x dx, that is equal to 2 into integral 0 to a f of x dx value. Okay na. Next case 2. So case 2 what we written again here, if f is odd function, if f is odd function, then f of minus x is equal to minus f of x, and equation 2 becomes again what ma, then minus a to a f of x dx value, that is equal to, here see ma, here again what 0 to a f of minus x dx, in this case what, minus f of x minus integral 0 to a f of x into dx plus integral 0 to a f of x dx, both are cancellation, value how much ma, 0 value. Okay na. So case 1 and case 2 if you get the value same, therefore what we have done, that given result, therefore what we have done finally, therefore integral minus a to a f of x dx is equal to, v1 function means if you consider 2 into integral 0 to a f of x dx, odd function means that value is equal to 0. So that is the 8th property.